Hey everyone, John Saville here, and welcome to this quick video on infrastructure as code for the IT admin. And specifically, I'll focus on how do we apply this for Azure resource creation and management. But really my goal is, as IT administrators, we probably keep hearing things about DevOps and CI/CD and infrastructure as code. And what does that really mean? So I want to start off with how we may, as administrators, be used to creating resources. I could, for example, go to the portal. I might want to create a new storage account. So I could go and look at my storage accounts. I could say add, and I can use a wizard. I can fill in the various details. I could create a new resource group, the name, the location, the type, the SKU, and then it will go and create it for me. And we really don't like doing this in production. This is a really bad thing because I can't really track exactly what I did. It's prone to human error. It's not repeatable. I can't manage it with change control. So while yes, I can use a GUI, we really don't want to do this. So then my next option as an administrator would be, hey, I can script this thing. So if I actually jump over here, I'm using Visual Studio Code, which we're going to get to in a second. I've got a little PowerShell script, and this PowerShell script is super simple. It creates a new resource group, so I can run that command. And then once it creates that resource group, I could go ahead and actually create a storage account. And I'm selecting the code and pushing F8 in Visual Studio Code to run the selected line or the selected block of code. And this is going to go through, and I can see, yep, it's created the resource group, and then it's going to go ahead and create that storage account. This is better than using the GUI. At least this is very specific. It's imperative. I'm telling it exactly what to do. I'm saying, hey, I want you to create a resource group this way. I want you to create a storage account this way. And so this works, and I could think about, well, maybe this is infrastructure as code. I'm scripting this thing. But the challenge with scripts is, for this basic storage account, this works okay. It's creating really two resources. If it errors, I can probably work out how to fix this. Now imagine it's a far more complex system. It's a multi-tiered service with lots of different components, and it errored halfway through. How would I fix that with a script? I have to go and work out, well, what got created. I have to have a lot of error checking, say, well, if this exists, if it doesn't exist. So it's kind of a painful thing. So we're not yet at true infrastructure as code. And there's my storage account. So that worked, but at least with this script, I'm going to go ahead and delete that. At least with this script, I could change control this. And that is a big part of infrastructure as code. So now let's actually think about a true kind of embracing this DevOps model, this infrastructure as code, this CI/CD. And what do those things mean? So really, continuous integration, CI. This is where developers can easily share code quickly through some continuous check-in of code, so I can easily see if there's any clashes happening into some kind of main branch. I don't have to wait until the end of a complete development cycle. And then continuous delivery deployment is the automatic build, the automatic deployment to environments if automated tests pass. So I want to be able to use that for my infrastructure. Now, before we get going with an example, there are a few things we need. So firstly, you saw me in Visual Studio Code. I definitely recommend you go and get that. So you can just go and do a search for Visual Studio Code. The documentation is fantastic. There's lots of different extensions for it. But yep, go ahead and download Visual Studio Code. And it also auto-updates, which is fantastic. So that's step one. I want this nice environment. I'm going to be able to, yes, I can create my PowerShell scripts. And I'm actually running PowerShell Core on this box. So that's actually a separate download. You don't have to do that. But I've gone ahead and got PowerShell Core version 6.1 currently. And then the other thing you're going to want is the Git client. This is a distributed versioning change management tool. This is where I'm going to be able to check in pieces of code, check out code, view the differences. And because it is distributed, I have a complete copy of whatever repository. Repository is where I'm containing those files, where it's tracking those changes. So I have a complete copy on my machine. And then I can synchronize it with a central repository if I want to. I don't have to. I could run this entirely locally. And I'm going to kind of talk about that briefly. So those are the things we have to get. I have to go and download Git and install it on my box. I want to go and download Visual Studio Code and install that on my box. And optionally, just for fun, I might want to use PowerShell Core, but I'm not going to cover that or really use it in this discussion. I'm going to focus more on templates. So I've installed all those things. I have my nice Visual Studio Code. Let's clear that away. I don't need this anymore. And what you'll see is you'll have Git installed. Now, one thing I am going to need to do is tell Visual Studio Code where the Git executable is so it can hook into it. Visual Studio Code supports Git automatically, but it does need to know where the exe is. So I need to show all the commands via the command palette. So if I do Control-Shift-P, it's showing it here on this first line. If I go and open my settings, I just need to override the Git location. So I would add this entry Git path, and that will now tell Visual Studio Code, hey, look, this is where Git is. And I have some other settings I've defined. For example, I've changed to use PowerShell Core instead of regular PowerShell. I have some different session environments, launchers I can leverage. I sync my settings, etc. But you don't need any of that. The only thing you need for right now is Visual Studio Code and tell it where Git is. So I would update that one entry. Once I have this, so what is infrastructure as code? What does it mean in an Azure world? And I want to move away from scripts. As I talked about, in a very simple way, yes, I can use a script. But it's declarative. I have to tell it exactly what to do. I have to handle exceptions. So instead, I want to use templates. Now I have a super simple create a storage account template. Now it's going to look pretty big compared to that very simple PowerShell script, but it's just pretty verbose. If you actually stop and look at it, it's actually very simple. And the key part about a template is it's idempotent. I can run these things as many times as I want. It's not going to damage anything that's already there. It will bring it into this configuration. And it's declarative. I'm not telling anything how to do something. I'm just saying this is what I want the end state to be. Now, if you go to GitHub, if you just search for GitHub Azure JSON templates, there's a whole set of these different templates available. If I actually look at a JSON, well, I have a schema that defines the content I can have. I have a version. I can parse it various parameters. So in this case, I'm passing it a storage account type. I have a default value, and I have a list of allowed values. My location, I'm going to use as the location of the resource group. When I deploy a template, I deploy it into a resource group. In fact, everything in a template has to go to the same resource group. I can define variables. So in this case, I'm creating the storage account name. It's just going to be some random unique string, adding standard SA to the end. And then for my resources, well, I just want to create a storage account with the name of that variable I define, the location I specify, and the SKU that I pass as that parameter. And that's really it. That's what this JSON template does. But this is the start of infrastructure as code. I'm using a template. And from this point, I could deploy this template from PowerShell through the CLI. I could even deploy it through the Azure portal. And that's great. But now let's start thinking about, well, how do I build on this? Well, I can have very complicated JSON templates. Later on, I'll show an example of a SQL cluster. But the first part is, well, I want change control. I want to be able to check things out, check them in, see differences, see versions. Now in Visual Studio Code currently, I have a folder open. I could go and do open folder. I already have that. So if I click the Explorer, I can see I'm currently looking at this folder, storage account local, and I can see I've got my JSON file, parameter file that I can pass to the JSON, and then my PowerShell file. But I have no change control. If I go to the source control tab, well, it's not registered. If I actually go and look at the file system, there's my folder, and there are my 3 files. So what I want to do initially is enable this for change control using Git. And it's super simple in Visual Studio Code. It's showing me here, well, there's no source control provider registered, but you'll see I've got this little initialize repository. That would run the git init command. And if I run that, where do I want to do this? And that's it. I've now enabled it for source control. And Git is very neat and tidy on my file system. If I change my view to show me hidden items, you can see now I have this Git folder. In fact, I also want to see my extensions. And that's where it stores all of its configuration, all of the different indexes, the various checkpoints, the commits I have. But I can now do change control. So the first step would be these files are all currently untracked. So I could simply say, well, let's stage all of these. So now the index has been added. And what I'm going to do is commit this. So I'm going to say initial population. And then hit the commit button. And now that's done. That's created me kind of a version in my change control system. It's all local on my machine. There's no remote repository at this time. I'm doing all of this locally. I can always go and actually look. If I scroll down, if I do show git output, which is actually difficult given my resolution here. Let's see if I can actually make this work. There we go. So it's showing me exactly what it did. And if we scroll up, you can see there's the git init. So that was it actually going ahead and creating that repository locally on my machine. At this point, if I close that down, well, I might start changing things here. Now what's happening, there are branches supported in change control. Yes, I have my kind of master branch. This is the main branch that's initially created. I'm probably going to use for the main deployments. But suppose I'm working on a new feature. I'm working on a test. I probably don't want to change that main branch directly. So what I can do, instead of changing the master, I could create my own branch where I can modify my code, I can test it. Then once I'm happy with it, I could then pull those changes into that master branch. So this gives me the ability to test and modify without any risk of polluting, causing any problems to those mains. So now with change control, I'm really getting into that idea of that continuous integration. I'm really embracing this infrastructure as code thing. If I actually open up quickly my terminal, if I do a get status, you can see I'm on the master branch and there's currently nothing to commit. Exactly what we're seeing here. So I could absolutely, if I go and click this icon here, this is showing me my branches. If I select this, I could create a new branch. And I could say test name change. So now it's actually switched me over to a different branch. And I could start changing things. Well, actually, I want to use the name instead. And notice it's flagging where I'm making changes. If I add new lines, it's showing me a green mark. If I delete lines, it will show me a little red triangle. So I can track exactly what I'm doing. And I could save this. Once again, I'm using change control. So after I've made a change, if I'm ready to commit it into my change control system, I would stage it so it's marked in the index, kind of ready to go. And then I could say, hey, change the name. And that's going to go ahead and commit that. Or I could switch back to the main branch, the master branch, and notice it's got the old data again. So they're completely separate. Now imagine I did all of these changes and I'm kind of ready to go. Now I've switched back to master. If I decide, well, actually that is the code I want, I can just go ahead and I can merge that in. So again, I have my different branches. I've got test name change. So I could say get merge test name change. I would pull down the latest copy if I'm using a remote repository first to make sure I've got the latest code. Oh, and I typed get wrong. Trying not to be offensive. And you can see it pulled it in, and now my master branch has that name change as well. So this is kind of the idea. I'm now using these change control tools, these versions, and I can go and look at the history and get full information on everything that's actually happening. And then when I'm kind of finished, I've done that merge, I could go ahead and delete that branch. So I could do a get branch, delete, test name change. I don't need it anymore. So this is all local, and that's great. And if it was just me, and maybe I was synchronizing this folder through something like OneDrive, this would float with me, and that's all I need to do. If I ever want to stop doing the change control, well, it's just this folder. If I delete this folder, realize it's going to delete all of that history, it's going to remove everything I've done, but it's that simple. I've now wiped away the source control, and I could initialize it again to start again. So that's all that's involved when I'm using these things. It's really that simple. So I'm just going to put that back to ID. Now, there are remote repositories. You've probably heard of things like GitHub. So I've got a little GitHub here, PowerShell Masterclass, I think I'm working on right now. I'm going to share the code with students via this GitHub repository. There's also Azure DevOps. So Azure DevOps was Visual Studio Team Services. It's now been renamed. And this is what I'm going to focus on for the rest of this kind of infrastructure as code demo. So let's actually close down some of these windows. Makes it a bit neater. I actually don't need that one either. So when I'm looking at my Azure DevOps, the first thing that I care about right now is the repo. So this is a repository. And here I can add in my various files. It's going to track history. For example, if I look at my storage account, this is that same file we were working on. I can go ahead and see the history. I can see the changes I've made, and I can actually go and look at the differences between any particular sets of versions. I can do comparisons, and I've got a whole set of files in here. And what I want to do right now is I want to work on this. I want to be able to make changes to this. I want to be able to work with others. Many people would clone this to their machines, and then we can work together in a collaborative way on this code. So I want to clone this project. So if I hit clone, it's giving me the URL that I can use. So I'm going to copy that URL. And now I need to go and grab a copy of this. Now I'm just going to show you this very simply just from kind of the command line. I'm actually going to, let's close this file. This is not the one we want anymore. And I'm going to close this folder. There we go. So the first thing I'm going to do is I'm actually just going to jump over to Explorer, and I'm just going to create a new folder. And you could obviously do this in PowerShell, infrastructure as code sample. And then we can create this a number of different ways. I'm just going to go ahead and open a PowerShell window. And there are extensions I should point out for Visual Studio Code that would enable me to do this as well. But if I go into my documents and my sample, it's an empty folder right now. So I want to go ahead and get a clone. So I'm going to do get clone that URL to my current location. So it's going to pull all of that down. I'll get all the files, and I will also get the Git subfolder. Remember, it's a complete copy of that. So I need to pick an account because it's a private repo. And now if I do an ls, there's all of my files. And I've got that hidden folder as well. So now, if I go ahead and open that folder, I have all the files from that project. It understands the source control. So it supports Git. Azure Repos is compatible with Git. I use the same client. So I can use the Get client with GitHub, with Azure Repos as part of the Azure DevOps. So now I have a centralized set of source control. So I've got all these files. So we're going to go back, and at this point, great. I have the same files. I could go and make changes. I would then commit them after staging them, and that would put them in my local copy. It's not going to send it up to that central one. So I can use this offline. I can use it on a plane. When I'm ready to share that to that central repository, well, via my source control, I can do a push. That would actually go and push it to the origin, i.e. that central repository. We're going to get there in a second. So this is a huge part of it. That centralized, this is the continuous integration. I'm using that shared repository. I've got full source control. I have these branches. This is a powerful thing we have right now. But the next step is, well, that's great. I've got the files. I've got the change control. That continuous delivery deployment piece, that's done via a pipeline. Now, in my case, I'm not building anything. I'm not building X's. I don't need that. What I want is to be able to release things. And I've already got one. We're going to come back to this in a minute. This is how I've done all this testing, and this is what we're actually going to use. But to show you how I can use that repo to actually do deployments, I'm going to go ahead and just create a new release pipeline. I'm just going to start with an empty one. You'll see here, I've got various stages. I'm just going to close that down for a second. I can name it something. So sample pipeline. Hit save. I need artifacts. So if I add an artifact, I'm going to add my Azure repo. I'm going to pull it down from this project. I want the master branch, and everything else I can leave as the default, so I want the latest versions. Notice I've got this little lightning. I'm not going to select this. I'm going to leave that blank. Now I can have multiple stages. Now notice part of these stages, I can add pre-deployment conditions. These could be, for example, someone has to approve something. These could be I have to manually approve it. I have to manually trigger it. I don't want to do that for now. I want to go and add a task. So you can see it's got an agent job. That just goes and grabs the contents of the repository. I want to do something. What I want to do is deploy this ARM template. So if I just search for ARM, there's an Azure Resource Group deployment. Perfect. Let me just jump back quickly. I want to make sure that resource group is gone. So good. That's disappeared. So we did that delete. So what I'm going to do now is go ahead and configure this particular action. So what I want to do is deploy to this particular subscription. I'm going to create or deploy or update, the resource group, RG infrastructure as code sample. I'm going to deploy to EastUS 2. I'm using a linked artifact. It's going to show me all of the content of the Azure repo. So I want to use my storage account. And then the parameters is my storage account parameter JSON file. That's only telling it any of the parameters that I've passed. In this case, if I actually jump over, you notice the parameters I can pass is the SKU. So my parameter file is just telling it the SKU, which is the default anyway. Not really that useful, but there we go. I want to do a complete deployment, which means anything that was in that resource group that's not in my template is going to get deleted. This is a complete every time, whereas incremental would just add the things or update based on my template. And that's it. I'll hit save. And I would normally comment this. So I've now created a pipeline. Well, that's great. Now what? Well, because of the way I've created this, I can now go ahead and create a release. This will run this. So if I hit create, I can see release 1 has been created. It's going to go through various stages. It's doing stage 1. It's going to pull the agent, pull down the various tasks, initialize, getting those artifacts. And it's going to go ahead and run the JSON file. And if I go and jump over, it created a resource group. And then within probably a minute, because it's deploying something, within about a minute, I'll see that storage account gets created. And that's finished. So it's about a minute. If I jump over, what do we have? We have the storage account with that random string name. And this is the foundation of infrastructure as a code for an Azure admin. Source control for my JSON templates, which is what I'm using to create resources, and then pipelines to deploy it. And at this point, I could go ahead and I can change the template. I could then push it. I could manually create a new release. But what about the continuous deployment part of this particular equation? So I'm going to go ahead and delete this. I don't actually have to delete it. I just want to kind of prove out a point. So I'm going to go and delete this thing and let that go ahead. So that was this pipeline. That's great. I'm just going to actually abandon this. And let's go back and look at all of our pipelines. So I have 2. I'm actually going to kill this one off. So now I have my main pipeline. And if I go ahead and edit this, you're going to see it's exactly the same. It's no different from the other one, except I've checked this continuous deployment trigger. And if we look at this, I've enabled it. All that means is every time someone pushes a new release to that Azure repo, it's going to fire off this pipeline. And what it's going to fire off is deploying the template. It's exactly the same as the other one. No differences at all. So let's actually see that in action. So I've got my repo, I've got my files, I've got my storage account JSON. And we can see it's using this unique string resource ID, which I've decided, I really don't like that. So back in my Visual Studio Code, I'm going to go ahead and say, well, instead of ID, I want to use name. I think that's a much better thing. And I don't want it to be unique string anymore. I just want to use the resource group name. I'm going to save that. As soon as I save it, it's now, if I go to my source control, it knows it's been modified. I'm going to stage it. Remember, this is all on my local copy right now. I'm going to say modify storage account name. I'm going to commit it. So that has committed it to my local repository only. Now, if I go and check out my status, you'll actually see I'm ahead of the origin master by 1 commit. If I go ahead and look at the code, well, it's not changed. If I look at the history, I don't have my new version yet. My content is still exactly what it was. I can go and check. Nope, it's still there. What I have to now do is push this to the origin. It was showing me kind of the status there. Now, if I actually go ahead, there's name. And what's interesting, if I go to pipelines, my release is, it's doing release 8 automatically. I didn't select that. It's just doing it. So this is exciting. All I did was submit the code and it's automatically doing that deployment for me. I'm going to look at my resource groups. There it is. And I'm going to get my storage account. This is so exciting. It's taking a little while and it's failed. If I go and look at my logs, deployment failed. Oh, it's got uppercase. I can only have lowercase characters. Big surprise to me, obviously. That's okay. So now I'll go back to my source control solution and I just need to make it lowercase. So, okay, I'm going to say to lower the name. Save that. Once again, stage it. Quick comment. Commit it again locally. And then push. Once I've done that push, it's going to trigger a new release again. Just refresh that. There, it's triggered release 9. Once again, it's now going to deploy that JSON template again. It's pulling down latest artifacts, doing that deployment. And this time, awesome, I'm going to get my shiny storage account. But you see, all I'm having to do is modify the code. And others could be working on this at the same time. Now remember, if I was working on maybe a big feature, I'm testing a fix, I'd probably create my own branch, and that's what I'd be deploying. I wouldn't be changing master. But this is the essence of this DevOps world. This infrastructure as code. I'm using templates, which are these declarative idempotent objects. I'm using a distributed source control that I'm sharing. And I've got these automated builds, and that failed again. Still in utter shock. Oh, it's all lowercase, that worked. Storage account must be 324 lowercase letters. Oh, I've got a dash in the name. Okay, we're getting closer. Back to my source control, I need to take out the dash this time. So all I'll do is I'll do a replace within the name. And I'm going to replace dash with nothing. Save it. Stage it. And I don't actually have to stage. If I just do commit, let's put a message in, removed dash, it will actually prompt me. And it will say, hey, do you want to add these? And I could say always, so it won't even prompt me with this anymore. But I want to have that control. The reason we do the staging is maybe I've changed lots of files, but I don't want all of them to go into a particular commit. So I can pick the things that I want into that commit. Now I'll push it again to that central repository. It's going to kick off release number 10. If I look at my repo, you'll see I have the latest copy of the file because I've been pushing it. It's the push that makes those changes go through. Go back to my pipeline. And remember, I'm not building, I'm releasing. Let's see how release 10 is doing. Fingers crossed this time. I'm going to get a bit further. And you see the idea. And this is the heart. That's all it is. I think as infrastructure people, we can get kind of intimidated when you hear the words DevOps and infrastructure as code and CI/CD. Infrastructure as code is simply I'm using templates to define the resources I want to create. Continuous integration is I've got this change management, in this case, distributed change management solution, so I can frequently check in the code, see what others are doing, spot mistakes earlier rather than wait until the end of a big project. That continuous deployment delivery, I'm automating these things via pipelines. And all of that builds up to make DevOps. And this one succeeded. I can see that all worked. If I go and look, this time I have my shiny storage account with the name of the resource group with standard SA added to it. So that was a super simple example, but hopefully you get the power of exactly what we're doing here. If I look at a more complicated JSON file, this is one I created for a customer. I'm passing a whole set of different parameters in here. I hook into Azure Key Vault to get sensitive passwords when I'm joining the domain. I'm doing a lot of different things in this template. I actually posted this to my saviltech.com blog. That's kind of an example of this. But I can do amazing things. This deploys a multi-node SQL cluster, joins it to the domain, adds all the extensions, adds the monitoring, all through this single template. So I hope this was useful. I hope this demystifies what can be very mystic, very unknown to us as infrastructure people. It's really just that concept that, hey, I'm using templates, I'm using source control, and I can set up pipelines to automatically deploy these. And I can add in checks along the way if I want. Someone can validate that. I can have branches so I can work on my own pieces of code. And I've got the links to Visual Studio Code, the Get client, and PowerShell core in the notes. Hope you found this useful. Please subscribe, give me a like, and good luck. Cheers, bye-bye.